Do I not have audio? I wonder if I do. So, okay, good. Could someone come off mute and say something? I'm not sure if I've got the room audio working or not.
Testing, testing.
There we go. Thank you, thank you. Okay, yeah, I did have something wrong here on the panel. That was weird. Okay, awesome. Okay, hey everybody. Here we are in session 11. It's like the end of July already. The term is just flying by. Um, Tonight, it's a super exciting night because we're going to start talking about Android um, and start talking about mob programming. So, lots of good stuff to look forward to. But let's start off with Prime Minister's questions. What can I tell you? There's been a lot of chatter, a lot of stuff going on, right? People finish up Project 3. Hopefully, people are starting to think about Project 4. Certainly, the quiz that's on Wednesday is about the web stuff, so you got to read up on that. What questions do people have as we begin class tonight? What can I tell you? How are people finding Project 3? Is it easier than Project 2, more difficult than Project 2, about the same? How does it compare?
For me, at least, I know that I'm just trying to understand all the expectations in terms of like what the format should be and what the expected output should be. So that's kind of where I'm at. I don't know where other people are, but yeah.
Yeah, thanks for sharing that. Yep, that's a big part of what I'm hoping that your learning is building up those critical thinking muscles and asking the questions. I think that's probably based on a lot of the feedback that you got on projects 1 and 2 about okay, yep, when people did miss things, it was yeah, probably because they didn't understand something about the command line format. So good.
I have a question about Project 3.
Yeah,
Um, what should the now when you say nicely formatted textual presentations,
yeah,
um, what should that look like for customer name, calling number, and caller number when we use the pretty print
yeah.
option?
So my expectations for the pretty print. Well, there are a couple of things. The pretty format, first and foremost, should be different from the text file format, right? So even if you think your text file format is pretty, the whole idea here is use something else. I'll also be looking, or I'll also instruct the grader to be looking for evidence that you've used that you've used some of the date formatting tools that are available with the standard Java API. So not just like calling toString on the date or having like the same format that's used in the text file, that you use something else. So I think there's been some chatter about this on Slack, like the format style. So format style dot short should be used for the get end time string, get begin time string methods. But feel free to use actually please use a different format for the pretty format. You could use medium or full or I think or long whatever it's called. But then also you can use date formatter datetime formatter dot of to provide something custom. Basically, again, what I'm going to be looking for is evidence that you've explored these APIs. And then otherwise, just making sure that it looks decent. I think with the phone call, you know how big all the fields are going to be, so don't so you should make sure that the text doesn't wrap funny if you're looking at an 80 columns and things like that. But overall, it's sort of I'm just looking for signs of effort that you've made things pretty. Does that help?
So mainly don't have it look the same as the text file.
Yeah, I think that would be like something where it's like, no, you're not going to get any credit if you just pair it back to text file. Something else coming in the chat. Is string.format good enough? Well, I mean, for some things, yes. For like if you want to like format a whole line that had like a phone number, or like for the duration, yes. String.format for like formatting like the duration, for instance. Yep, that would be fine. And if you wanted to use things like, hey, this is, this column is 10 characters wide and right justified, and put your put a phone number in that. Yep, that would work. So yes. I think though when it comes to formatting dates, well, you can use, I guess you can use string.format to format dates also. Again, just as long as it's not the toString value of the local date time. I think that'll be good enough. So let's see here. So technically print out a nice way, just like how you would do for a customer. Yes, right. The pretty format is meant to be consumed by a person, by a human. So it's not something that's parsed by the program. It's something that the grader looks at and says, okay, yep, I can understand that easily and not have to like put a bunch of pieces together. Anything else that's on your mind? Project 4, anybody have a chance to dive into that yet? Any questions there? Hope everybody had an opportunity to at least get it building from last week, as we saw it there. Oh, good. Thanks for confirming that you built it. Yep. So now it's just a matter of simple matter of getting to work. I do recommend that you study the code that we wrote on last Wednesday when we factored all of that stuff. As a matter of fact, feel free to start from there. Take things like the servlet and just paste it into yours. You'll want to use your own phone bill and phone call and text parser and pretty print and all that kind of stuff. But it'll save you a bunch of time, and it's the reason we went through that whole refactoring exercise is to give you some better code in the servlet and the unit test to start from. So let's see here, some program notes. So let's see here. Wednesday, it's our first in-person mobbing activity. And so please come to the classroom and please bring your HDMI adapter. Oh, I thought I had put that as a reminder here. But yeah, so we have 5 stations here in the classroom for doing mobbing, and I think with this many students, we'll use all of them. So if you have an HDMI adapter, please bring it so you can plug it in to the projectors so that lots of people can see it. I was hoping to do an operating theater in the classroom tonight, but only one other student showed up. Thank you, you're awesome. But 2 people does not a mob make. So then I think what we'll just do is we'll just review the mobbing content instead, and we'll talk a little bit about it. And then we'll just, I guess, try it. So then that's good. I do see the question. I'll get to that shortly. So let's see here. So tonight, next Wednesday, we're here in the classroom. Next Monday, I've had a personal commitment come up, and so there's a high likelihood that I will pre-record the content for next Monday, which is basically me programming a bunch of Android code in front of you. And so I will let you know as soon as I can. Hopefully I'll know on Wednesday whether or not I'm available for class on Monday. But otherwise, just I'll bang out I'll produce the video, the recording, the pre-recording over the weekend, and let you know about it. And so take time on class on Monday to review that. But then the Wednesday after that, on August 7th, that'll be our second mob programming activity. And we'll do that. You can attend remotely, or rather, you can participate in mob programming remotely. However, I was the one that graded your reflections on pair programming, so thank you for doing that. I think you all had some good observations about the experience, and a number of you called out that there was a difference between the in-person and the remote. Most people said that that remote didn't go as well because it wasn't as a real-time interaction, and I've found that in the past that's amplified with mob programming. So as we see today, it can be difficult to come down to campus, especially when it's rainy out. And it wasn't just here, like everything was just so dead. I was walking around campus like, where is everybody? It rains and everybody stays home. And maybe that's what happens. So anyway, next Wednesday though, I do encourage you to come to class both on the 31st and the 7th. I think you'll have a better experience mobbing. However, to be clear, in-person participation is only required on the 31st. If you want to attend remotely, you can do so on the 7th, although please do attend remotely. But then, gosh, we're at the end of the term. This is right, isn't it? I mean, final exams are on August 14th, so we've only got a couple more weeks left, which is kind of crazy. So things are certainly coming in for a landing here. One more question. Oh, sorry.
I was gonna ask a question about the final, because I saw there's like a group. You may have explained this already, but I saw there's a group thing or like a group grade on Canvas and then a single. I was wondering if you could talk more about that.
Yeah, sure. I'll provide more details. I don't know, next week sometime. Yeah, there are two portions of the final exam. There is an individual and a group portion. Let's see here. I'm pretty sure. Yeah. The final exam, we'll do that in person. So please plan on, even though, well, shoot, I don't know if we're actually, let me think about that and we can talk about it. Because it is administered on Canvas. So why would I bring everybody to class if it's on Canvas? Okay, yeah, so I guess not. We'll talk more details about it. But yes, the idea is that, yep, most of it is individual on your own, answer questions in the group portion. But the group portion is not coding, so it's not mobbing or pairing. You've already done plenty of that. It'll be a small group discussion instead. And that's probably much I'm going to say. It's not something you can study for. It's something that I want you to, it's a creative activity that you'll work with other people to achieve.
Gotcha. I was more just curious about like the in-person versus not.
Yeah,
No worries.
Meh. We'll see. Maybe I'll take it. No, I won't take the night off. I'll be here. I'm getting paid to be here. Let's see here. Yes, remote would definitely be more convenient for folks. A question for Project 3. I do have one question for 3. Are we going to have new errors for invalid dates and times, like if the date is 14/32/2000, where the month and the date are not possible, or time like 2590, where the hour and time is not possible either? I'm not going to test that. So I mean, it's whatever the Java APIs do. But no, I'm not going to test the semantics of the date, just the syntax of the date. Nice. Okay then. Any other questions? Anything else I can answer for you before we get started? Earlier tonight, I sent out a summary of everybody's grades to date. I didn't realize that quiz 4 hasn't been graded yet, but I did want to sort of give everybody a heads up of like, here are the grades that I have. If anything is missing or messed up, please let me know. Okay. Okay, we are getting into the final weeks of the course, as we said. Oops, let's go tonight. Wait, this isn't right. I need to refresh this. I moved some things around. I guess I can refresh this tab. Nice, okay. So tonight we're going to begin exploring really the final 2 major topics in the course, and that's Android development and mob programming. They don't have anything to do with each other, but they're both the most advanced topics in the course, and I think the Android development will give you an opportunity to leverage all of the Java programming skills, plus their API, the Java, your familiarity with the Java API, and the tooling that you've. Oh, sorry, another question came in. Okay, never mind. Okay, nice observation. Thanks, Sam. And it'll also give you the opportunity to leverage leverage IntelliJ in the tooling that you've learned. In Project 4, when we created the web application, we started over from scratch with a new project, and we're doing the same thing in Project 5. Not only will there be a new project, but it will be an Android project, which is really quite different from the Maven projects that you've been dealing with in assignments 1 through 4. There's a lot of tools that you use to build an Android application, which probably isn't terribly surprising. And I've found that sometimes the tools don't work on everybody's machines, especially if you've got an older development environment. So one thing that I want to make sure that we do early is make sure that everybody has the ability to build an Android application. And if for some reason you don't, then you and I can figure out how this is all going to work. But it's been a while since anybody's had a problem, so hopefully everybody's got modern enough machines. Certainly the tooling has gotten better about supporting different architectures and stuff. So what we're going to do for the first half of class tonight is that we're going to install Android Studio and create a skeletal Android project that we'll then use for the basis of Project 5. And I'll introduce Project 5 next week, but long story short, it's basically writing an Android app for your phone bill application. We'll get into the details next week. But first, let's start with Android. So let's see here. There's a lot of steps here, so I created some notes that I'm going to then to the tab. Cool. And these are notes from me to follow along. And they're kind of rough, so it's not like one of the other handouts. So let's see here. The first thing that we need to do is we need to download the Android Studio. So Android Studio, sorry, I guess I will go to the assignment. And I'll post this URL here shortly. Yeah, here it is, developer.android.com. So what we're going to do tonight is we're going to download Android Studio, and then we're going to, let's put this in Slack, I guess. Download Android Studio, the IDE for developing Android apps. Let's see here. Is the Android Studio download through the JetBrains toolbox the same as a regular Android Studio? I think so. I don't know. Yeah, I don't know. I haven't been using JetBrains toolbox very much, but it probably is. So if you go to developer.android.com, you get this page, and so you can download Android Studio. Brings you off to this other thing. I just used the latest version, which is Koala. And Android Studio is really great. Actually, let me just get through this. This will take a while. Let's see here. I have a Mac with an Intel chip, and oh, I have read that. And so I'll get that started to download. It is not small by any means. So Android, as you'll learn about in that first Android lecture, is was originally developed with the Java programming language in mind, and as a result, much of the Android ecosystem is based in Java, and there's still a lot of Android applications written in Java. That's what we're doing in this class. There's also an alternate language that the Android folks support called Kotlin, which you can use to develop Android apps. And Kotlin is a different language from Java. There are there's some admittedly nicer syntax for certain things. However, I'm not going to make everybody learn a new language here with weeks left to go in the class. But just be aware that many of the examples that you see online and a goodly amount of the system is oriented towards Kotlin and not Java. Now, the real reason that there's this new language is because Google and the Android folks got into a big fight with the Oracle and Java folks back a long time ago, and the Android folks realized, okay, we should probably have a safer language that doesn't have someone trying to claim a lot of copyright on it. And then again, Oracle paid good money for Sun Microsystems and the Java language, so can't blame them for trying. So I downloaded Android Studio, and by the way, I encourage you to follow along at home so that you can make sure that you can get Android Studio working in your environment. So I'm going to move this out of the way. And so I'm opening up the installer here, and on the Mac, you just click and drag to install into applications. And there it goes. It's going to do its thing. So Android Studio is really great. It is based on IntelliJ. So the Android folks worked with the JetBrains folks to basically have a customized version of IntelliJ that is optimized and oriented towards developing Android apps. So this is really great because Java developers get a very consistent and familiar experience for building Android applications. And so, let's get all this stuff out of the way. There it is. It's installing. Again, the software is not small by any means. Okay, and it's all set. So now I'm going to launch Android Studio. Oh, am I running IntelliJ? I'm not. Good. I found on my laptop. By the way, my laptop is super old, but it works. I can't. It's really slow to run both Android Studio and IntelliJ at the same time. So I'm trying to conserve my resources so that we don't take too much time just watching me download and run things. Okay, did it launch? It did. Okay. Yep, it's an app downloaded from the internet, and I want to open it. Thank you. Yeah. I think it's time for a PSU to buy me a new laptop. Thanks. Yeah, actually, I probably will get one here pretty soon, but I really like my old MacBook Pro. I mean, this thing is, you're right, I'm getting to that age where it's oh no, I like my computer the way it is, even if it's really slow. It doesn't have one of those little bars up top where you can do the autocomplete and everything. It's come on, give me a break. No, this is good. And by the way, as an adjunct faculty member, PSU doesn't buy me laptops. I buy my own laptop. Oh, there's Android Studio. Okay. It is asking me if I want to import, the touch bar, yeah. Oh, good, they got rid of that. Excellent. Because I've run Android Studio a lot on this machine, it thinks there was an old version. I think I've deleted everything, so I don't want to import any settings. I'm just going to start over from scratch. You may or may not see that. You probably won't. And, okay, yep, now it's running Android Studio. It's getting some stuff. Okay, great. So Android Studio is like IntelliJ, but there's a whole suite of Android tools that you need to build Android applications. I talked about some of these in the lecture. There's a couple of things. There are the build tools for essentially compiling and assembling the Android application. And then there's also the emulator. So one of the things that we'll see tonight is that when you develop an Android application, you want to be able to work with it and test the application on something that closely resembles a device. right? I mean, we don't have to go out, because you don't have to go out and buy like a physical piece of hardware for all the different types of devices that you want to develop with. So instead, what Android provides is is an emulator for Android devices, and then you get system images, which basically give you virtual devices on top of that. We'll see all that stuff later. So the first thing that you need to do, though, is you need to set up all these things with Android Studio. And luckily, Android Studio makes it super easy. The first time I tried to first time I taught this, there was lots of manual steps that you did to download and get all this stuff. It was kind of a pain. It is so much better now. Just for the sake of simplicity, we'll just start with the standard installation. So the first thing that it asks you to do is specify, well, actually, it downloads a bunch of default build tools. Right now, this is version 35, which ought to be fine for this course. This is what I get on my Macintosh. If you're running on a different system, you might see different things. Of course, there's all licenses. I've read these licenses many times, but you please feel free to make your own decision about how deep you want to go into all this stuff. And now I'll go and download, and this will take forever. So there's again a lot of software that you need to build an Android application. So but Android Studio takes care of getting it all from Google, installing it in the right places, and making sure that everything works together. So you have an integrated development environment, right? So all your tools are there, and it's easy to build Android applications. So while this is downloading, I'll pause for questions or any feedback. For people playing along at home, have you been able to download Android Studio, install it, and get kind of this far in the process? I'm recording right now. Pretty good. Oh, it's downloading now. Same. Yeah. Oh, nice. Good. Some people got heads up. Okay. Good. Okay. So after it downloads some of these large files, it starts it starts installing them on my local machine. Good deal. Extracting all sorts of stuff. So again, so Android is built on top of the Java platform, essentially. So one of the cool things about Android applications is that you have access to kind of a large swath of the standard Java APIs. So you've been learning about working with files, you've been working with the collections, date formatting, all that kind of stuff. Maybe not date formatting these days, but a lot of the fundamental tools that you're used to in Java are available in your Android app. And so this lends a lot of familiarity and power to the platform. Okay, it's downloading the emulator, and it's installing some stuff. Okay, it's creating something called an Android virtual device, and well, in a little bit we'll see what this is all about. But the whole idea here is that you can have an emulated device here in your development system. Okay, so yeah, it created one that emulates the Google Pixel Fold device. We'll be using a different device. Fold is a little too new for my tastes, and the aspect ratio is wrong, right? We're on a phone app, so we'll create a Pixel one here shortly. Okay, so now we have set up Android Studio. And now it's started up. Now, as those of you may remember, this is how IntelliJ looked for you the very first time that you ran it. It said, great, well, how do you want to get started? And we want to create a new project here. Okay. And so it gives you this this palette of new projects, and I want us to start simple. So I recommend that we create an empty views activity. These other ones are are kind of neat, but they're a little, they come with a few too many bells and whistles, for lack of a better term. It's a little too complex to get started with. I want us to start off super easy so that we can really learn about the fundamental pieces and not get bogged down in some of the more complex, complex UI widgets and navigation components that are available in Android. So we're going to start with an empty views activity. So select that one, and not to be confused with an empty activity. You want an empty views activity, and not a basic views activity. You want an empty views activity. And so then click next. And now it asks you to provide some information about your project that you're going to create. So the name of the project is, call it Phone Bill, and the package name, we'll just call it edu pdx cs.joy and then your user ID. All right, and the save location. So where I want this to go is in your repository, in the GitHub repository that you created for your let's see here, for your project. So let's see here, Joy of, oops, where did it go? Where is, okay, sorry, Joy of Coding PDX. And yeah, here's my summer 2024 repository. So I'm going to start with that, and then inside that, I want to have it be in phone bill -Android. And actually, it's really important that you call it phone bill -Android because it's what the submit script will look for. So just to emphasize that again, we are adding a new directory in your summer 2024 repository. This is where your phone bill project goes, where your phone bill web project goes, and now you're having a phone bill -Android directory. You want to choose the Java programming language for this project, not Kotlin. And for minimum SDK, I recommend 33. I think that gives you enough newer APIs, but it's not totally leading edge. And for the build configuration language, please use Groovy. So to reiterate, for those of you playing along at home, the name of the project should be Phone Bill. The package name is the same package you've been using, so edu pdx cs joy, and then your Linux user ID. The location should be in your Git repository, in your GitHub repository. So find the local checkout of that, wherever you made the local checkout, and then specify that you want this project to be in phone bill -Android. You want it to be in the Java language, and you want the minimum SDK to be 33. And please use the Groovy build.gradle, Groovy DSL, not the Kotlin one. Okay. Once you do that, click Finish. And it will download a bunch of stuff, and will install some libraries that it needs for this code. And it'll also, okay, it looks like it's also downloading version 34 of the Android SDK. That's cool. Okay, and there we go. So we'll finish that. And now it's opening up an IntelliJ project. Well, sorry, an Android Studio project. Because it's built on IntelliJ, things ought to look familiar to you. Okay. Oops. Okay, let me make it a little bit bigger so we have more screen real estate here. Okay, so it's IntelliJ. So over here on the right, there's some information about what's new in this version of Android Studio. That's super cool. Oh, someone asked a question. Should I add files to Git? The answer is yes. We'll get to that shortly. But it sort of tells you, hey, what's new here? Complains about my version of Git. That's fine. After you can close that there so you can see more of it. There are more questions. The package name was the same as the package name that you've used in the other project. So it's edu.pdx.cs.joy. Your Linux username. Yes, thank you. Enjoy. And yep, looks like people good. Looks like people are getting started here. So as you can see, IntelliJ is doing all sorts of stuff in the background. It's analyzing files. It's starting to build the project. It's looking at all this good stuff. And so then, so I'll just keep the chat open because it looks like people are having good conversations. Yep. So yeah, you can feel free to add those files. I guess it didn't prompt me, probably because I hit cancel too many times in previous usages of it. But we'll get there shortly. Actually, maybe I should just do that now. So if we go back and look at, yeah, here's my, yep, here is my, check out my repository. And now if I do a git status, if I do a git status, it says, oh, look, you've got a new file called phonebill-android. And that is true, I do. I want to add this to Git. I can do it from the command line, or I can do it from IntelliJ. I'll also do it here from the command line because I'm already there. That's nice. And it's got a gazillion, it's got a lot of files, and we'll look at some of these. Maybe some tonight, but probably mostly on next Monday when we dive into into writing the code. But lots of good stuff here. So I'll just say git commit added Android project source files. And I'll push that up to GitHub. Nice. So now everything is in, everything is in Git. And we're looking at all sorts of source code. We're not going to really look at the source code tonight. I think I will save that for when we, when we do some coding. But I think I do want to do a little bit of a tour here of what we've got. You can navigate the project, all the files in it in various views. This is the Android view, which gives you a nice Android-centric view of things. There is source code. There is Java source code. So there's something called a main activity, and so this is Java code that executes your app. There is something called resources, and these are additional configuration files that do things like specify the the visual layout of the app. This app out of the box is very simple. It just says "Hello World." That's what you get, and we'll look at the main activity again a week from tonight. And then you've got these things called Gradle scripts. So Gradle is the build system that's used with Android apps. It is the successor to Maven. And I find that the learning curve for Gradle is kind of big, and I could go on about why I prefer to use Maven in this class at the beginning instead of Gradle. But the Android folks use Gradle. There's not good Maven support, never really has been. And so then this is what we use. There's only one change that you will need to make, and we'll talk about that a week from tonight. So all sorts of good stuff happening there. Oh, and then manifests are files that describe your application. Again, we'll talk about that later. So these are the kinds of things that you get. So out of the box, you have this Android app that will just display "Hello World." Now, over here on the right, I want to highlight a couple of things. Yeah. There's the device manager. So this is the thing that manages all of the virtual devices that you have. And when we went through that initial setup, it created a virtual device for a Pixel Fold. Right? That's some phone that Google makes. Or some device. I don't even know if it's a phone. I don't for this project. I don't want to use a Pixel Fold. I want to use a sorry. I don't want to use a Pixel Fold. I want to use a regular Pixel. So let's all create a new virtual device, and it will be a Pixel 5 because I mean it's sort of the right dimensions for the app that I want us to build. So choose a new Pixel 5. Click next. And now we got to choose an API. I think 35 is the one that I used. I want to check my notes here to make sure I'm getting this right. Yep, Pixel 5 API 35. So I'm going to click. I think either one of these is about the same. So is there a difference between the two? Yeah. I'm going to do that. Okay. And so now it is downloading the version 35 binaries, if you will, for the Pixel 5. Oh yeah, this takes a little bit. A couple questions have come in. Can you go back through how you did the last part really quick? I missed a step. Which last part, where we started creating the device manager? Or, sorry, we started creating it. Yeah. Okay. Maybe I can. Maybe I can't with these modal dialogues. I can't. But anyway, we'll do that up here. So over here on the right, there is the third button down on the right hand side displays the device manager. So this is the emulated Android devices that you have access to. So out of the box, I think you get a Pixel Fold API 35, and that's not the one we want though for the project. So under the plus button, you can create a new virtual device, and that is the workflow that I have in progress here as it very slowly downloads over the PSU internet, PSU Wi-Fi, a 1.3 gigabyte file. I chose the Pixel 5, so we're going to create a Pixel 5 API 33, 35. Pixel 5 API 35. So actually, sorry, let me just say Pixel 5 API 33. Nope, 35. Keep in that wrong. Oh, and I should send it to everybody. Just curious why you prefer the 35. It's newer, and so I think that gives a couple more APIs, and yeah, and the build tools match 35 also. The sleek aerodynamic design. I don't know. Gentlemen prefer the 35. I don't know. Okay. Does that mean older Androids could use the app? I mean, if they had 35, yeah, but maybe not. So yeah, but I think you're bringing up a good point. I mean, so if anybody's got like an app of their own, sorry, if anybody's got a phone or a device of their own that they want to try to run it on, neat, but that's very much bonus credit. What I'm going to grade you on, so I just want to make this crystal clear at the beginning, is the Pixel 5 API 35 emulated device. So that's the thing that the project must run on. Okay, it downloaded 35, got everything installed there. Now it's asking me for some information about so AVD is Android virtual device. I'm just going to call it Pixel 5 API 35. Sure, accept all of the dimensions and things like that. Yep. Start up in portrait mode, etc. And now finish. Okay. So I'm going to get rid of this Pixel Fold just by deleting it here. I'm not gonna use it. It's just going to get in my way. It's just going to take up space on my machine. So yes, I really do want to do that. Okay. So now I've created a virtual device, and now I want to start the virtual device. Now, I was doing this over the weekend, and it said it's starting up, and I think it's going to fail. Looks like it did, which is actually what I expected to do. It's just thinking about something. Oops. Yes, it's still starting up. So what I discovered over the weekend is that this latest version of the Android emulator doesn't work very well on my probably over 10-year-old laptop. But there was a slightly older version. Oops, I don't know, something. It's thinking about something, but it's probably failing because it didn't take this long before. Oh, there it is. The emulator, right, has terminated. which is what I see on my machine. Now, I hope that out of the box on your presumably newer machines, it works. So let's see here. What did other people have to say? Oh, good. Seems to be working for you. That's good. Okay. I'm going to run through a couple of steps right now that will resolve the problem. Just kind of bear with me. But if you encounter problems, let me know, and I can probably help you work through it. Again, everybody thinks that the CS department has money to buy me a Macintosh. You think your tuition's high now. So let's see here. I'm just going to go through some steps here. Basically, what I'm doing is just installing a slightly older emulator that works on my system. I don't know how much max RAM you should allocate for the emulator. I encourage you to do some research to figure out what a good number is. Tax deductible expense, yeah, if I still itemized. Now that I can't deduct my my mortgage payment, doesn't make sense to itemize anymore. Let's see here. I want 32,114. 32, 114. Well, the emulator should have been installed as part of the Android Studio process. So interesting. Oh, had to select a little down arrow to get it start downloading? Huh. Yeah, because for me, it downloaded the emulator as part of installing that initial setup of Android Studio. Oh, sorry, can I? Oh, there it is. No emulator. Oh, click install emulator and see what it does. That's interesting. Okay. Thanks for checking in on that, though. Okay, I'm going to see if I can. Actually, I'll try it from Android Studio again, see if I can start it. So I believe I installed an emulator that will work on my machine. At least this all worked yesterday. Where are the devices yet? Oh no, it looks like something's starting up. I can tell from the from that there. And as I recall, the first time it starts up, it takes a while on my machine. Oh, there it is. Good, that's making more progress. So, failed connect within 5 minutes. It hasn't been 5 minutes yet, has it? Oh, maybe that was the old run. Yeah, that been the first run that it failed after 5 minutes. So I think it's doing okay. There we go. Yes, yeah, good. Good. Looks like Angel is having fun playing with his simulated Pixel 5. So, as you can see, there's something that looks like a Pixel 5. And this is what the emulator gives you, right? It lets you develop and work with something that behaves exactly like that device. And this is really powerful and really important, right? You want to make sure that your application behaves well on a variety of devices. Now, for this course, we're just doing one. So that's good. And for me, it takes a long time for it to start up the first time because it's got to boot the phone, essentially, and it's got to initialize everything. Because what you're actually running is exactly the same image that the hardware device does, right? And this is one of the great things about Android. When you know, when Google joined forces with Samsung and other people to launch Android, you know, the whole idea was is that in the Android ecosystem, you had a number of different devices provided by different manufacturers, different vendors that all shared an open platform for developing small device applications, as opposed to the more closed system of Apple and the iPhone, and the iPad at the time, where it's much more controlled. There's one hardware vendor, there's one software vendor. Definitely has its advantages in some scenarios, but Android took a different approach. And so as a result, there are lots of different devices from different vendors that you can emulate. We're going to choose the Pixel 5 because I know it works. Still starting up, taking a while. But as you can see, it's running here right inside of Android Studio, and so then as we'll see next week, maybe I should start today. I don't know. We'll we'll see that we can start making some changes. It's very easy to make changes to your application and then deploy them immediately to the emulated device. There we go. Luckily, I found that it only takes this long the first time it starts up because there's some boot up procedures, and it should. Oh, actually, yeah, maybe it doesn't have anything yet. No, it should. It'll get there. When I run the device, I like to undock it here, and so it's got another window that you can see. That's really interesting. Yeah, my computer's kind of hard. It's also running Zoom. It's probably using a lot of processing power, especially for the video stuff. There we go. Now it's coming in. And so, again, it's a phone, right? And so it's got a whole bunch of really interesting information about it. You can, I don't know, you can do things like, just the volume, you can turn it on and off, you can rotate it, right, to see what it looks like. And, here again, you can write an app that will respond to that rotation and go from a portrait to a landscape view. You can access the camera, and I guess we can record there. Somewhere here, let's see here, what does this thing do? Oh, layout inspector, that's not really what I want. I think, there used to be. Let's see here, you can zoom here. If I just right click on it. Oh, maybe it's not while it's running. There's all sorts of different, there are all sorts of things you can configure about the device. Like, oh, good. Thanks for asking those questions about the 35 and everything like that. But yeah, as Angel mentioned, you can do things like run the Chrome browser on your emulated Pixel phone. And it's the real Chrome browser. You have the same experience. Nope, it crashed. It might have. Anyway, it's super fun. Oh yeah, people running on Windows have to do the HaxM stuff and everything. Yeah. I haven't do that in a while. So my experience is that it's way easier than it used to be, and but if you do run into problems, you can usually get things working with a Google search. Looking for Stack Overflow articles and things like that. Because we're not alone in this ecosystem. Lots of people are trying to try to get this stuff working on their devices. Yeah. So here is here is your mobile browser on the emulated device. And then as with all Android devices, you've got the 3 buttons. I can never remember what does what. So you can go to Overview, and yep, that'll bring us back here. And so now you can click and drag the app to delete it. But you go down, swipe down these days. What is it? Oh, swipe up. Yeah, swipe better. There you go. And it's deleted. Now you're back here on your home screen. So this is the emulator, right? And it looks like people are, most people are making progress, getting it to work on their machine. So this is how you, work with your app. Now, the other thing is that you want to deploy your app. And IntelliJ makes it super easy to do that. It's, sorry, I got to move the Zoom stuff out of the way. So if, one of the things that looks familiar in Android Studio is that they have run configurations, just like you do in IntelliJ, right? Where you would say, oh yeah, go, run my command line program, or go, go to the debugging configuration so I can attach to the debugger. You have the same thing in Android Studio. So you choose the device that you want to deploy your app to, and there are, well, I guess you can have app configurations too. But then you click Run, and what this will do is it'll build the application and then deploy it to the app. So all this is taken care of for you. So again, Android Studio does what IntelliJ does, right? It knows about your app. It will compile all the source code. In the case of an Android app, it will compile all of it so that it can be deployed to a device. It assembles all the stuff that it needs to do. And then we'll create an APK, which is the package, basically, and then deploy it off to the device. And it takes care of all of this for you. And so then this makes for overall pretty rapid development for Android apps. And of course, if it encounters anything wrong along the way, like a syntax error or something else it can't build, it'll give you IntelliJ-like feedback on what happened. So there it is. It deployed the app, and there's the app in all of its glory. It just says "Hello World." And so you can go back into the home screen. Here is the icon for it. Here it just shows up as a default little Android icon. You can click on it to launch it again. Oh, looks like the app might have gotten deleted from underneath you. I don't even know how you delete the app. That's impressive. Let's see here. Is this something here? Well, and if you haven't, I'm trying to think. Okay, so deleting the app. How do you do that? You remember how you did that? Was it just in the configuration up here? Because you might be able to create a new one. Yeah, you can probably create a new one. The 3 dots next to the red square. Oops. Oh, is my Android Studio no longer responsive? What's going on here? Ooh. I think Android's, oh, there it is. Good. There's the, I'm going to cancel this before it'll let me do that. Oh, yeah. Delete, yeah, okay. So basically, I think what you need to do then is you need to recreate it by doing edit configurations, and you can add a new one, a new Android app, and actually, yeah, let's just see what that does. New Android app. And you can give it a name like app, and then the module is phone bill, and I think all this other stuff is the same. Yeah. So hopefully that's not too difficult to recreate. cancel, does it still show up? Yeah, it's not there. Save. But cool. So I think that's the Android stuff that I wanted to show off for tonight. I want to make sure that everybody can get up and running, and it sounds like most people who said that they started, have been able to get pretty far. Hopefully, as far as I did here. I don't know if I can resolve all the problems right here and now, but has anybody encountered any impediments to being able to run their Hello World app in a Pixel 5 API 35 emulator? Good, thanks for the indication that it's working. Cool. Okay then. Hey, let's take a 10-minute break. We'll come back at 7:12, and I'll talk about mod programming, I guess. We'll see you then. Recording. Awesome. Okay, welcome back, everybody. At the beginning of class, in the first part of class, we got started with Android. We installed Android Studio. We downloaded a whole bunch of stuff. We installed a bunch of things. On my machine, I had to go install an older emulator that works with my ancient operating system. And then we ran the emulator and deployed our application to it. And it's a simple Hello World application. We'll just make that bigger so we can see it. Yep, all it does right now is display Hello World. So that's what I wanted to get accomplished with Android tonight. I did see a bunch of chats go by. I didn't have a chance to look at them. So what we got going on? Looks like we're doing a little bit of debugging or a little troubleshooting with a couple of students. Thank you very much, especially on Windows. I appreciate all of the good collaboration and stuff. Yeah, there might be other. I'm sure there's an emulator for your phone. Might just go find it. I'm not sure how to do that. Looks like yeah, you're figuring it out. Good, good, good. Well, and so good. I hope this piques your curiosity, and gives you something to look forward to for Project 5. Well, you gotta get Project 4 done first. So between here and there, you got some REST API stuff to learn about, but it's all good. Sure, it'll be fun for you once you get to it. Before I move on and talk about mod programming, are any other questions for about Android that I can answer for you right now? Cool. Okay, let's talk about mobbing. Keep that handout also. Okay. Yeah, I guess I'll share this. Oops, with anybody. Go slow. Go. Oh, and copy link. Always do that. There we go. Oops. Oh. Oh, actually, now I'm curious to see what it was. Oh, yeah. The CRLF line. Yep. Yeah, I think I usually do fix and commit in this case, although my git config probably set the auto CRLF a long time ago. But right, the whole idea is that, yeah, if you're working on Windows and Unix, which you are, you want to make sure the line endings are platform dependent, and then Git is smart enough to sort of understand differences between line endings on certain platforms, and it gets it right when you say the auto CRLF. Nice. Okay, let's talk about mob programming. So, a couple weeks ago, we got to experience pair programming, which is two people sitting at a computer working together to solve a problem. We did a couple of katas, and we're going to be doing the same thing for mob programming. In both cases, we're going to leverage test-driven development for figuring out how to implement the katas and the best way to approach the solution. So mob programming takes a lot of the ethos from pair programming and amplifies it to an entire team of developers, usually about 4 to 6 people, right? And so then you have a bunch of people rallying around the problem and bringing their experiences and their skills to solving it. So what we'll do starting on Wednesday and then the next Wednesday is break out into little teams. We will work on a kata, and we're all going to use that shared GitHub repository again, so that all the code is visible and so that we don't need to spend time setting up a new repository each time. Now, I was hoping to do an operating theater exercise tonight, but since there's only 2 people in the room, and I'm one of them, it won't be much of a mob, and I don't really want to start with a remote mob. I think that will be a little challenging. So I'll maybe we can spend a little bit of time on Wednesday doing an operating theater exercise. I really want you to be able to see this before you have to do it. I think it'll make a much more compelling thing. So maybe our first kata, we won't get as far as we would have otherwise, but that's the way it goes. Oops. Looks like I didn't update this URL. So I'm going to just do that real quickly. Creating PDX, and then katas summer 2024, and then the tennis, which I think will work. Oops. Yeah, let me fix that. Why? Can I find it? Yeah, it exists. Okay, cool. Anyway, we'll do that next time. But I want to give an overview and talk about it now so that we can hit the ground running on Wednesday. So if there's a motto for mob programming, it's all the brilliant minds working together on the same thing at the same time in the same space and at the same computer. This was a development technique that software developers at a company in San Diego started doing probably closer, if not more than 10 years ago now, to basically amplify all these good things that they saw out of pair programming. Sort of ask themselves, well, if it's good for 2 people to work on it, why not the entire team? And what they found is that by having more people contributing to the software development process, not only did they get better results faster, but the knowledge was spread amongst the entire team. And this is one of the aspects of mob programming that has always resonated with me. In my career, I've seen lots of teams and organizations stymied by siloed knowledge. Oh, there's that part of the system. Okay, there's only one person that can work on that. Or it's like, oh well, we used to have 5 people, but then 4 of them left, and there's only this one person left, and only one person remains who can contribute to it. And this has all sorts of negative consequences. There are negative consequences on the individual, right? That person will get pigeonholed if they don't want to do it if they don't want to contribute to that anymore. Well, too bad. No one's going to help them out because no one else knows how to knows about that. But there's also consequences for the organization to having siloed knowledge and siloed skills. In that, boy, when that person goes on vacation, the work stops. No one else can do it. Boy, if they really would like that person to work on something else, they can't because again they're siloed. But mob programming solves that because when done well, everybody is engaged, everybody's paying attention, and everybody's learning together as the code is written. And so that makes for a much more resilient team and therefore a much more resilient organization and software development system. As I hope that you saw in the screencast about mob programming, there are lots of concepts that are borrowed from pair programming as a starting point for mobbing. So there are roles, and actually the mob programming community has defined a lot more roles than the pair programming community. Not surprisingly, they're looking to help multiple people understand how they can contribute to the mob. But there is a driver and a navigator, and it's very much the same as it is in pair programming, where the driver is the person whose hands are at the keyboard, referred to as the intelligent input device. So the whole idea is that they're writing the code, they are operating the IDE, right? So they're driving the machine, and the driver. Just like actually even more so than pair programming, there is a conversation that takes place in mob programming. And so it's the responsibility of everybody in the mob to use their voice and to ask for something they need or to help the conversation move along, help the work move along. And so then the driver may say things like, okay, well, tell me what to write. Or, okay, we were just talking about doing something. How do we test that? Right? And so then the driver can start the conversation by putting the questions out there of what to do first. Now, in mobbing, it's also important that there's a navigator. So this is the person, and actually really the only person the driver listens to. And so what the navigator does is it takes the ideas and the thoughts from the rest of the mob and then delivers those ideas to the driver. And one of the challenges that the navigator faces is making sure that the information they provide is at the appropriate level for the driver, making sure that it's just high level enough so that the intent is clear to the driver, but not so low level that the driver feels insulted, for lack of a better word, because they're being told exactly which key to type in which order. Oops. Okay. Now, in many respects, because there's an entire mob, everybody except the driver is a navigator of sorts, right? Everybody's expected to contribute their ideas, their thoughts, be part of the conversation. But the navigator is really the designated navigator. That's the person that the driver listens to. But the navigator also has responsibility to the rest of the mob, which is to encourage people to speak up. And this is really important. The dynamics of the mob and the success of the mob really relies on people feeling safe to be able to contribute their ideas, to be able to engage in the conversation without fear of retribution or ostracization. When there's only 2 people, it's much easier to manage the dynamics. But when you start talking about 4 or 6, all of a sudden, you need to be on the lookout for people who are quiet, or for people who are dominating, or for people that are checked out, right? If you go and look at the lecture notes, there's all of these roles, and there's some patterns and anti-patterns for mob programming. So you've got the driver, you've got the navigator, and then you've got the mobs, the mobbers. That's everybody else. So these are the people that inform what it is that the designated navigator ultimately delivers to the driver. And also, because you have more people there, you have an opportunity for a little bit more parallelism in the work. So for instance, it's completely appropriate for a mobber to do a little background research right? Maybe you're writing some code and you're trying to figure out an API. Well, it's a mobber can say, oh, I'm gonna go look that up, and they go quick find the API documentation or a good Stack Overflow article or whatever that explains how to solve the problem at hand. Another really important aspect of mob and ensemble programming, and I think this is where it really has a lot of benefit over pair programming, is that mobbers who aren't the navigator or the driver can perform things like capturing learning. And this can be basically writing the technical or developer notes for the code, recording why certain decisions were made, taking putting down reminders of like, oh wow, we had to right now this part of the system is broken. Here's how you go and fix it. Or oh how let's take a note for later to go back and try to automate that process that was really manual and frustrating. And this is where you get the benefit of all the brilliant minds, all the brilliant talents coming together. And this is how you end up with a faster, higher quality results faster when you pour more minds on the problem, because you have multiple people, multiple CPUs, multiple cores, all contributing to the problem, helping things go faster. So there are the roles. If you go and look in the slides, I have a whole bunch of sort of sub-roles within that, which I think are good things to keep in mind. But for us, as we do mobbing for the first time, let's keep it simple, and we'll have a driver, a navigator, and a mobber. Now, just like with pair programming, it helps people sustain their engagement and continue to feel like they're a part of it when they have an opportunity to change roles. So as you all know, I'm a big advocate for Pomodoros, for working for several minutes at a time, doing getting something done within that time box, doing a brief retrospective on how things went, and then changing roles. This way, everybody gets to experience the different roles, see what they like and they don't like, but it also helps them see the roles from different points of view, right? Like when you're, when you're a navigator, if you know you're going to be the driver next, then you can pay special attention to what the driver is doing and say, okay, look, they just learned, I just learned a keyboard shortcut from them. That's really cool. I want to use that when I'm the driver. And so again, switching up roles over time helps everybody be more focused and stay that way. So a couple of things that I want you to keep in mind while mobbing and ensembling. When it comes to speaking, you got to figure out what that level of abstraction is appropriate for the particular driver. And I think especially with this group where everybody's still pretty new to tools like IntelliJ, to aspects of the Java API, making sure that you sort of test it out through discussion. What is that? What's the right level of abstraction? So you can say something like, well, write a unit test that does this. So that if the navigator says that, the navigator needs to be tuned in to the driver to figure out how they interpreted that. Yeah, maybe so. Some people will be like, oh yeah, right, gotta write the test annotation, and then I have like a void method, right? So they might be able to do that just fine. But if you sort of see a pause, or maybe someone who seems a little unsure about it, ask them, oh hey, would you like me to say more about that? And if they say yes, then say, okay, yeah, start out with an @test annotation. And you like capital T test, right? Those kinds of things. Again, it's a conversation, and what we're really looking to do here is learn through application, learn through solving a problem. And so then it's completely okay. As a matter of fact, it's really healthy for individuals in the mob to practice, to learn there with everybody else, because everybody has an opportunity to provide inputs into that learning, and then everybody gets to observe that learning in real time. Mob programming calls out 3 core values. That's kindness, consideration, and respect. Please keep that in mind while you are working with your mob. Everybody comes bringing their best. Of course, also brings everything else that happened to them that day. So some people might be in different states of attention, different states of understanding, and this is how we show up. And in order for the mob ultimately to be successful, we all win or lose together. It helps to be kind. It helps to be considerate of others, and then just show respect. Another key aspect of ensemble programming is inviting people and allowing people who are maybe quiet or have the least privilege within in the mob an opportunity to contribute. Rotating it does this, but also just listening for maybe someone who maybe their body language is saying they want to contribute something, or saying that wow, this person hasn't had an opportunity to contribute, and I don't know if it'll happen here in the classroom. Maybe it will. Someone who traditionally hasn't had that seat at the table, hasn't had an opportunity to really contribute, or maybe it hasn't had, or maybe it hasn't been given the opportunity to contribute. Ask them. It's like, oh, hey, what would you do in this situation? Or hey, what are you thinking about? And maybe the answer will be like, well, there's nothing I want to contribute right now. That's absolutely fine. But let's not miss an opportunity to bring everybody into the conversation so that we can have the diversity of ideas that will help us find the best solution for the problem. And again, the lecture notes talk about this more advanced roles like automationist and traffic cop and anthropologist and things like that. Cool stuff, good to know, but probably not where you want to start. So at least for the first night, let's just stick to having a driver, a navigator, and a mobber. If you haven't already, I would encourage you, actually, please do review the screencasts and the lecture notes all about mob and ensemble programming. I think it'll help you come in and more quickly get up to speed and be able to approach the work at hand. If you want to learn more, I recommend these resources. These are the resources that I go to when I want to learn about mob programming. Everything from books to the role-playing game designed by Willem Larson, to a really great podcast called The Mob Mentality Show. Yeah, there's a lot of mob programming, but gosh, they put out a new episode every week, and they have all sorts of interesting people from the software development field that bring their own experiences and their own perspectives on what's going on. So this is mob programming is really still considered quite leading edge even in software development, and I think it's there's some good lessons to be learned to apply to how software is built in the year 2024. Any questions or thoughts or observations about mob programming? So on Wednesday, we'll start out with a brief operating theater exercise. Probably lasts about 45 minutes. I'll try maybe only half an hour. We'll see. 4 or 5 people, with 5 people in the mob, 5 times 8 minutes, 7 minutes. Yeah, 7 minute round followed by a 2-minute retrospective followed by a 1 minute. Okay, yeah. Too bad we couldn't do that tonight. That's the way it goes. And then everybody will be mobbing on the bank OCR kata, and we'll talk more about that on Wednesday. And I will merge in a bunch of projects to the repository for that, so that we can all get started. And so what we'll do is we'll we'll mob on that, and then we will capture, and let's put some more rows on this table. I will then we'll capture our learnings in this retrospective format, where we say, well, what didn't, and what ideas we have for the future. So preview of coming events. Okay. So let's You want to do some more Android stuff? Get started? We got time. So this is stuff that I would have prepared for, well, actually, it is prepared, but I would have delivered it for next Monday. But instead, let's spend, well, I don't know, another 20 minutes or so, maybe, yeah, until 24 minutes. We'll stop at 8 o'clock tonight. Doing some Android stuff. Okay. So, a question came in, which was, oops, there we go. It's like, okay, well, where does this hello world come from? I'm looking at the source code here, and the main activity has got like all this Java stuff, but nowhere does it say anything about hello world, right? You don't see the string hello here anyway. Like, how does all of this work? So let me navigate around the source code for a while, and I will have the emulator up and running just so that we can see things. So, Android has these things called activities, and activities are basically the screens in your application. And so, this first screen, this main activity, simply has hello world. It just simply displays hello world. Now, if you read the lecture notes, you'll understand what the content view is, and that's got, the out of the box has this, okay, whatever this insets listener is, and it enables edge to edge, whatever that means. But activities have a life cycle to them, and the whole idea is that when an activity is displayed or when it's created, the onCreate method is called, and the onCreate method essentially initializes the activity. In some respects, activities are like servlets in that they sit there and run, and they receive input from the user at any time. Eventually, we'll see buttons and input fields and things like that. But for me, they seem like servlets in that they're like an object that's instantiated at some point, right? There is a constructor here, but it's not something that we work with. Instead, we work with the onCreate method. Just similarly for your servlets, you work with like the doPost or the doGet method as opposed to a constructor. So activities have something called a content view. Now, a view represents a displayable widget. Or a series of displayable widgets that are all nested inside of each other in your activity. And so then you set that content view to be the value of this r.layout.activity underbar main. As you'll learn about in the Android UI lecture, R is this like magical class in Android that stands for resources. So the behavior of your application, of your app, which means like, here's how I'm responding to a button click, or oh, hey, I am initializing my activity. That happens in Java code, and Java is really good at that, right? Java is good at expressing behavior because it has things like for loops, and you can call methods, you can do all that kind of stuff, right? So it's good at the behavior side. Java isn't a very good choice for when it comes to describing a UI. Say, okay, well, listen, I've got this button here, and I've got this text field here, and that's the, this thing is to the right of that thing, and oh, by the way, it's all centered. At the end of the day, yes, it's all code that runs, but Java isn't a very good language for expressing that. And it certainly doesn't work very well with tooling. However, so what Android does is it has XML files that are used to render, or rather not to render, to specify how UI widgets are laid out. And you can navigate to that XML by clicking on this activity main. This brings you to, I'm going to make a little bit more screen real estate here. This brings you to a, hide this. As you can see here, what we're doing is we're viewing this activity underbar main.xml. So this is the XML file that corresponds to the main activity. And what we're looking at is this kind of WYSIWYG version of it. But we can look at just the code right here. And here you've got this big old XML file that describes the widgets contained in this layout. So at the highest level, there's something called a constraint layout, which is a special layout for basically saying this, well, we'll see in a second. And then inside that layout, it's got a text view. And so this is actually a description of a text view object, text view widget. And it's got all this configuration, including that the text displays is hello world. And so there you have hello world over there. So this is the XML. This, the nice thing about XML is that it's text-based. You can put it in version control really easily. The tool can parse it and understand it. But it's not terribly convenient to work with. What Android Studio gives you is this WYSIWYG, what you see is what you get, rendering of this XML that's a little easier to understand visually. So as you can see, it looks just like the app when it's deployed, right? You get this big square saying, hey, here's your app. It has hello world in the middle. And you can interact with it. So for instance, when you click on it, when you click on hello world, over here on the right, it all lines, it lights up over there. And if you've noticed that over here in the XML, it now highlights text view because that's what you've clicked. So if I click the constraint layout up here, it actually selects the entire thing. It's not terribly obvious. But I can click here, and I can do things like drag it around. And when I drag it around, things change over here. So like, for instance, it got this, it went from, this here, it changed these two lines. You can tell because it's got the get blue lines right there. And what it did was, it added a new attribute to the XML element saying that its constraint vertical bias is 0.372. I don't really know what the hell that means, but that's what happens when you make a change over here in the WYSIWYG editor. Oh, it looks like it took that out when I moved it back. That's kind of nice. Probably a more interesting change is to change the text. So I'll just say, hello, joy of coding. Okay. The text now shows up over here as hello, joy of coding. And so I've made a change to my application. And now notice when I'm still running on the old device, it's still running the device, the old version. So I can I can deploy that by clicking the run button here. And what this will do is it will rebuild the project, and it will deploy a new version of the app off to the device. So I made a simple change, and now I'm going to deploy it off to the application. Yeah, it's taking its own sweet time. It'll get faster after everything warms up. There it is. It stopped the old application, and it's deploying a new one, and now it's going to relaunch it. There it is, and it now says, hello, joy of coding. Okay, so this is basically how you deploy. This is how you develop an Android application. You sit here in Android Studio, and you make some changes. If you're making visual changes, you look here in the rendering of the XML, and then you deploy it off to your app, and you interact with it to see how it works. Now, over here in my XML, this thing is underlined in yellow, and it's saying hard-coded string hello joy of coding should use @string resource. Yes. Okay. So. You want your apps, whether it's like an Android app or it's a a website that you're building or whatever. In many cases, you want strings that are displayed to the user to be localizable, right? Meaning that you can you have all the strings extracted outside of the code itself, so that you can translate them into different spoken languages, different written languages, so that they can be consumed by people that read or good English. And so then Android has really great support for that by using something called, well, resource files. So here I can use IntelliJ to show the context actions, and it'll fix this for me. You can say extract the string resource. I can do that. So it'll create something called a string resource. I'll call it hello, joy of coding. Here is the value. And it says what resource set do you want to put it in. I'll just have the main. In the strings.xml. We'll take a look at strings.xml shortly. And so then we will say yes to do that. Now the yellow line goes away, and that's replaced with this string that says @string / hello, joy of coding. So Android, and you'll learn about this in the lecture, when you see something in an XML file that begins with the @ sign, it's a reference off to something else. So you see like @ID and things like that. Here it's an @string, where it's saying, hey, listen, this is referring off to the string resource. And so if I command click on that, that will then navigate off to, well, that's nice. Okay. That navigates off to the strings.xml file, which defines a couple of strings that are used throughout the application. One is the name of the application itself. And then this one that we just added, you can tell it's added because it's got a green bar next to it, called hello, joy of coding, which has the string, oh, hello, joy of coding. And what this allows you to do then, what Android Studio encourages you to do, is to take all the static strings out of your code and out of your layout XML and put it into a resource XML, the strings.xml, so they can be translated easily. It's easy today. Okay, and so once again, you can deploy this code right here. Because I made some changes, I'm going to commit these changes up to GitHub. And I'm going to say extracted a string resource for the hello string. Hit push. I saw a chat go by. Does someone have a question? Can you show me how to change, oops, sorry, can you change the view to code view for that file again, please? Yes. Yeah, so if you're back in, I'll show you how to get there in the first place. You go to the main activity. Actually, you can do a couple of things. I think you can also navigate it by clicking on this. Yeah, you can go to the layout files. So you can either click on this reference to it here in the set content view, or you can click on this little like XML icon to go to related XML files and go to the activity underbar main. And then here, just let me make things a little bit bigger so you can see everything. I'm going to minimize this guy and I'm going to minimize that guy. You can navigate between different views by using these three icons up here. So the icon on the right is where we start, is just the design view. Then you've got the split screen where you've got the XML over here on the left and the design view on the right. Or you can just click on just the XML if you just want to see that. So another question, why are there two versions of the screen in the activity? Do you mean these two versions, the white one and the blue one? Yes, I'll take that as a yes to this question. I don't know exactly, what is this one is some sort of like architectural view. I knew at one point. Let's see here. Sorry, I want a little more screen with real estate. I forget what the purpose of this one is. Oh, neat. There was a way to turn it off. Where was it? Select design surface. Oh yeah, the design and the blueprint. I don't know what the blueprint gives you exactly. Maybe it's a more abstract view. So like if you are really focusing on the design, then it's not so much about the specifics. I'm not sure, quite frankly. You could also choose like light mode, dark mode, and stuff like that. Sorry, night mode and everything. Well, you can also change locales. Yeah, neat. So yeah, that's what that's for. I think it's kind of a design thing. I have to admit, I Don't know exactly what that one was all about. Yeah, the views of the content. Again, I think if you are a designer, the view on the right might give you a more abstract view of what's going on, and then the view on the left, of course, is more of an attempt at rendering it in a way that you can also edit it. Yep. And I think someone's also pointing out that there's this palette over here on the left, and we'll see that, maybe shortly. Let's see here. Okay, so one more thing that I want to show. Actually, I need to go back to my notes to make sure I'm going in the right order. Yeah. Okay. So what I'm going to go through, I'll start tonight, and then I'll record some stuff, over the weekend or whatever, so that you can play it back on Monday if that comes to pass. I'm going to take this simple out-of-the-box Hello World program. I'm going to turn it into a calculator app. Of course, right? It's always a calculator app. Either that or a bookstore, or it used to be a video store back in the day. We don't do that, right? But like, a simple calculator app to show you how you can build an Android app. And so the first thing I'm going to do is I'm going to, what I want to have on this first screen is a button that I click to launch my calculator. So I'm going to, for tonight, I'm going to show how we can turn this thing into a button. Now, someone pointed out there's the palette over here, and I suppose I could try this. Yeah, let's give it a try. You can always undo it. Oh yeah, I'll definitely upload the recording. I'll try to get that done tonight. So I'm going to just select this. I'm going to delete the text field there, so it's gone. Actually, if we then go look at let's do it side by side with the XML. Oops. Yeah, it's gone from the XML now. Yeah, I'm gonna try to get the palette. Is this too ugly? It's kind of ugly. I change. There you go. You don't need so much of the XML. I'm instead going to put a button on the screen here, and so I'm going to put the button on there, and I'm going to change the text of the button, which I could do over here, but I want to show the attributes. So attributes, these are all of the attributes of the widget. It's all the stuff over here in the XML attributes. But what I always do is I always search for the attribute that I'm looking for. I'm looking for the text attribute. In this case, the text right now, it just says the button. I'm going to say launch calculator. So I'm going to change that there, and okay, it impacts it there. It changed launch calculator. It is yellow over here because it's saying it should use a string resource, so I'm going to extract a string resource for it. And yep, sure, it's called launch calculator, so it's happy there. And now I'm going to deploy my app and see what it looks like. So I've got that button there. Now, the button's not going to do much, right? If you go to click on it, it's not going to do anything because we haven't told it what to do, but we'll get to that next. Okay. It's launching. There it is. Yeah. Okay, so there it is. Got the button. Oh, look, the launch calculator is just like up and to the left. Why is that? Well, you may have noticed that in the XML, there's this red underline in the button. What does that say? This view is not constrained. It only has design time position, so it will jump to 0, 0 at runtime unless you add the constraints. How? Okay, we need to add constraints. And that's true. If you may recall, there were like the squiggly lines and stuff. So I want to get the squiggly lines back by clicking on the button here and dragging it to the top, and clicking on this anchor here and dragging it to the bottom. And then we'll do the left side, and then we'll do the right side. And now it's fully constrained. There's no more red. And this is what you have in a constraint layout, right? You can use these anchors to position it. So now if I redeploy it, we'll see that the launch calculator button ought to be displayed there in the middle. Now, if you look at the, when you watch the next lecture, the next Android lecture, you'll learn about all sorts of different layouts. There are basically these view types, these view types that allow you to, that themselves aren't displayed widgets, so it's not like a button or a text field or whatever. It's instead a view that lays out other widgets. And actually, we'll be seeing one next time that lets you lay things out horizontally, and so the whole concept might make a little bit more sense. But hooray, I've got a button on the screen now. But when I click the button, it doesn't do anything. I'm clicking the button and nothing happens, which is true, because it tells it to do anything. So ultimately what I want to do is launch the calculator activity, but we're not going to get to that tonight. But I do want to show off how you can respond to a click event. Right, so conceptually, like the thing that's different about UI programming is the following. So for command line programs, and certainly the ones that you write in this class, it's kind of a straight line thing, right? You type in java-jar, and then you give it all the arguments and everything like that, and it executes the main method. It starts at the beginning of the main method, it does, reads the command line arguments, it does whatever the main method does, and then the main method it returns, and then the program is done, the process exits, right? That's what the program does. It's sort of a one and done type thing. You just run it, and it starts and it stops. Now, with your web server, for Project 4, your web container, right? You start Jetty, you run your application in it, and then the user interacts with it by calling REST APIs, and their state is maintained there. And that's a very different kind of application than your main that just starts at the beginning and stops at the end, and it's all done. The Android app is much more like the web app in that the Android app is running and the user does things with it. Right? It clicks on buttons, it inputs text, the user drags things around the screen, draws, does all those interactions. And so what your code does is then responds to those interactions. Now, when it comes to handling like the mouse click and everything like that, and routing it to the right place, the Android runtime does that. But ultimately, just the same way that your servlet has to provide a particular response to a do get of that particular URL, your Android app needs to provide an appropriate response to a button click. So the way that it does that is there is a property of the there's an attribute of the button called onClick. And so you set the value to the name of a Java method, which is called when the button is clicked. So I'll call it launch calculator. Oops, calculator. And so I just set it there, and notice that it updated here in the XML. And it's underlined in yellow because, well, there is no method called launch calculator, but Android Studio can create it for me. So I can do the, there you go. Create, it'll ask me if I want to create it. I say, yes, I do. And so now it brings me to the editor for the for that Java code for the main activity. Come on, sorry. Zoom is getting in my way. So here I am in my main activity, and just added a launch calculator method. So this is the thing that is launched. This is the method that is called when I click the button. Now it doesn't do very much of anything, so I'm going to have it. Do something. And the easiest thing that I can do is launch what's called a toast. Now a toast puts a little piece of text up on the screen. So there's this API in Android called Toast, and you can say, hey, make some text to display on the screen. And so it asks for a couple of things. The first thing is the context, which is going to have this object. This is kind of like the anchor that the toast is displayed against. You can put it in a character sequence so that you can say, I'll say launching calculator. And we'll see what this is displayed to. And then the duration, there are a couple of constants. We want length long. So what this will do, oh, what doesn't it like here? It says, toast created but not shown. Did it forget to call show? I forgot to call show. Thank you. So I'll call show. Yay. Thank you, Android Studio, right? It's, I'd forgotten that part of the API, and it reminded me about it. So now what this is going to do is this then provides the response to the button being clicked. So again, what we did was let's go back to the XML. We added, we added an onClick method, that's our onClick property, to the button, which calls the launch calculator method. And when the Android compiler, when the Android builder goes and looks at the XML file, it goes off and tries to find the launch calculator method on the activity associated with this layout. And it looks for the launch calculator method, and it makes a connection between the button and the launch calculator method. So now I'm going to pop this out so it's bigger, so you can all see it better. Now when I click launch calculator, it pops up some text down at the bottom saying launching calculator. That's the toast. So this little piece of text right down here, that's the toast. So I think it's like raising a toast and launching a calculator, because that's a good excuse to have a drink. So, ultimately, these are the fundamental steps for creating an Android application. You have an activity. You populate that activity with some widgets, with some visible views by editing the XML file, most conveniently with the design view right here. And then when it comes to interaction, what you do is make a connection between the widgets and the Java code by doing things like defining an onClick method for the widget to then go to a particular piece of Java code that is invoked in response to the interaction with that widget. And what we'll see next time is the continued evolution of this application. So what we're going to do is when you click Launch Calculator, it'll take you to a different activity, to a different screen that has the calculator. We'll populate the views there by adding some text fields and a button to perform a simple calculation based on the user input. And then we'll implement the ability to return to this main activity and then keep track of all of the results of the calculations in a list, and also write it out to a file to see how all that can be done in Android. And those are basically the pieces parts that you'll need to implement your Project 5. And we'll also talk about Project 5 on next Monday also. So while I commit this, any questions about what we saw just now in terms of adding a launch calculator button to the Android app? Okay. Well then, we'll head out a little early tonight because we didn't have a chance to do the mobbing. I expect us to go until at least the end. Maybe we might take a couple extra bonus minutes next on Wednesday to make up the time. But we'll all be here, so I apologize if that messes with people's schedules. But might need to make up the time to make sure that we all have a good opportunity to experience mob programming. We're looking forward to Wednesday. I'm looking forward to seeing you all here in the classroom. Remember, bring your HDMI adapters if you have one, so that you can take advantage of the awesome projectors that we have. I will see you then. Have a good night, everybody.